All right, here's where I nerd out a little bit, but this is, when I learned this in grad school, it was like the biggest damn revelation. And it really helped me to understand statistics in general, because I felt I had learned, the genesis point for a lot of statistical pieces. And this is a piece where we'll talk about how ANOVA and regression are actually the same thing. So our ANOVA formulas on the right here: grand mean, individual score, mean of the group, and sub J. So all of those pieces that we've already talked about. But those are our formulas. We're going to focus on those three formulas, but we're going to compare them to regression. So sums of square total. So ANOVA versus regression. First thing right off the bat, you see X's in one, Y's in another. That's just notation. We could call our stuff in ANOVA all Y's, and it would be a little more clear. Again, two procedures developed by two people who hated each other, did not respect each other's work. And we'll see, ironically, those two racists ended up in the same damn place. So sums of square total. What is this telling us? In both cases, it's telling us take the value of your variable, subtract from it the mean of all of the scores. Different notation, same concept, same exact thing. Between group and regression, I'm going to show that those are equivalent. Within group and residual, I'll show that those are equivalent. So again, I kind of jumped the gun on sums of square total. I've already told you this. In both cases, we're just taking each individual score and subtracting it from the overall mean. Both ask the same question. The notation is slightly different. Sums of square between and sums of square regression. Well, we established the grand mean, that the first two values were equivalent, that what ANOVA calls the grand mean and what we just called the mean in regression are the same thing. Now, Y prime was a predicted score, prediction along a regression line. X bar sub J is the group mean. When we have groups, our prediction for any individual score in that group is simply whatever the mean of the group is. So the mean of the group is actually just a predicted score. It's what we would predict if we had no other information. If we know somebody's in this group, our best guess, our most accurate guess, is going to be whatever the mean is. So X bar sub J is actually equivalent to Y prime. So Y prime, Y minus Y prime minus the overall mean in both of these cases, or predicted score minus the overall mean in both of these cases. So those are equivalent. And what I'm going to say now, well, should not shock you, sums of square within and sums of square residual, those are also equivalent. Those are also equivalent. X bar minus X bar sub J, that is taking the individual score minus what we predict it to be. Same thing as with regression, exactly the same pieces. These are totally equivalent, so much so that I could actually calculate these as a regression. I've just called Y prime I've simply called Y prime here I'm simply assigned as Y prime the mean of each of the groups. You can see 3.5, 3.5, 3.5. That's why we have that shortcut where we can just multiply by the n. I've calculated Y minus Y bar. You see that summed it at the bottom to 26. I calculated Y minus Y prime in this context, summed it to the bottom, calculated as 8. Y prime minus Y bar, calculated those, summed at the bottom to 18. Exactly equivalent to the sums of square we got from the ANOVA approach. Again, the reason for that is these are the same values. In fact, Fisher would probably hate this. People routinely will say ANOVA is simply a special case of regression. It's a case of regression where we have groups of points rather than points along a regression line. But we have simply groups of points.